Hello and welcome back to the YouTube channel. Today on statics problems in the real world, we will be completing the whining problem. Oh, gotta make sure. Clicked on the PowerPoint. Okay, today on this whining problem, we're going to be working with two concepts: friction in lecture 22 and tightening a screw in lecture 23. The learning targets that are going to be used today are using friction, understanding simple machines, understanding tightening against W, and calculating moments. This machine that we will be dealing with today is a wine bottle opener. Ooh. Wine bottle opener is used to open up wine bottles by pulling out the cork. There's two main components in a wine bottle opener. First is the mechanism to get into the cork. In this case, it is the corkscrew. This corkscrew is pushed down with a force of W, and a moment is also created by turning this tab at the top with your fingers, and with the combination of forces between the downward force, in this case W, and the moment created by turning the tab at the top to turn the corkscrew into the cork. It is created by the radius and lead, the lead being the distance between one thread to the other, and the radius being from the center of axis to the outside of the thread. The second main mechanism in this wine bottle opener is the two arms on the side. The two arms on the side are used after the corkscrew is in the cork, and they are both pressed down perpendicular to the arm itself. In this case, to create a mechanical advantage to pull upwards. The mechanical advantage is created by a longer distribution of force. The force is farther away from the center where the moment is created in both of these screws that pivot, and creating an upward force to pull the cork out of the wine bottle, giving you your wine. Okay, so our problem states Mark is having a wine night with his bros when his static mind hits him. He notices that the corkscrew is being driven into the cork. He is applying 10 newtons of force on each end of the tab with his finger. Mark wonders how much force it takes to puncture the cork. Lead, radius, and friction between the steel threads are given in the figure to the left. Starting off, we will address the three components at the end. Lead, as I said in the last slide, is the distance between one thread to another. This is often vertical. It'd be easier to show on this diagram. It'd be from one thread to the other going downwards. In this case, it is 1.5 millimeters. The radius in this case is measured from our red center dot of the corkscrew to the outside of the corkscrew. And the friction coefficient between the steel on steel threads of the wine opener are found to be 1.15. Those numbers will all be used in equations in the next slide to solve the equation. The orange arrows are representative of the forces created by your fingers turning the wine bottle. This is the top view, of course. The purple rectangle here is used to represent the tab at the top of the wine bottle opener that your fingers press up against. This gray represents the corkscrew. The gray represents the corkscrew here, along with the corkscrew over here. This is the side view. The thing labeled cork is the cork, and the green is the wine bottle itself. As you can see, the cork is still in the wine bottle in this situation, and the corkscrew is not yet into the cork. The blue represents the moment that we will find by the two forces of our fingers pressing in the same direction. And the black arrow is the downward force that we have to find to actually puncture into the corkscrew. We will be solving this using two main equations. The first is sum of moments. Actually, we are just going to figure out the moment using our two fingers, the 4 millimeters that it is from the center of the axis to our fingers, and the 10 newtons of force pressed by each finger. This could also be solved using another equation, but we're going to do it this way for this problem. Next would be using the tightening against W equation in lectures 27 of the PowerPoints. So given this equation, we're going to find theta and phi. You find theta by taking the inverse tangent of the lead divided by 2 pi r, r being radius. And phi using inverse tangent of our friction coefficient. Given these, we are going to solve for W, the force it would take to puncture the cork, and we are given a force of 199 newtons. Things to think about in this problem would be how the lead, if lead was increased, would the force that it takes to puncture be greater or less? If radius was increased, would the force needed to puncture the cork be less or greater? This could also work vice versa. But those are a couple of points of discussion that could be talked about. The second problem statement says, while Mark presses down on the two arms of the wine bottle opener, he notices that 50 newtons on both arms. He needs to press 50 newtons on both arms to start to raise the cork. Knowing that the friction coefficient and the distances in the figure to the left, as shown over here, Mark wonders the normal force acting on the cork from the bottom. So first, going on our variable that we're trying to find the force that the wine bottle, in this case, is pressing on the cork. It could work either way, it doesn't matter. But in this case, we're going to say, what is the force that is pushing on the wine bottle, on the cork, my bad, from the wine bottle? Given variables in this is 50 newtons of pressure pushed down from each side. Each side is one arm, and they are 30 millimeters away from the center of axis. The center of axis is 5 millimeters away from the corkscrew. This gray rectangle represents the corkscrew again, and the corkscrew is now in the cork. And we're looking for, given that the friction coefficient is 0.65 between the cork and the bottle, we need to find the force of friction between the cork and the bottle. To find this, we're going to use two equations. The first is summing of moments. To figure out our sum of moments, we are going to take our 50 newtons, 30 millimeters away, and there's 2 of them, so we need to multiply by 2 to give us the force that is pressing upwards. But because force is pulling it up, our friction is going down, so that's why we need a negative over here. So the friction, the force of friction between the bottle and the cork is 600 newtons. Given this 600 newtons, we would plug it in down below here and divide by 0.65 to get 923 newtons is what the bottle is pressing in on the cork. Some parts that could be discussed in this problem would be what different friction coefficients of glass and cork can be. When I looked up to try to find the friction between glass and cork, there wasn't a really defined number, but there was it varied a lot. So would increasing the cork to glass coefficient make it harder, make the normal force greater or less in this problem? And then again, where you put your force on the 2 arms of this problem also can create a different problem and change up the numbers in the end. In conclusion, where could this fit in and how could it help? Well, the part 1 of the problem that dealt with dealing in the screws would be in lecture 23 that dealt with screws. It would be in the tightening against W section. This requires a different equation than loosening with W and other equations. But I think this would help out for reason 1 being that it is a object that is well known and people would understand what the radius and lead is if they could imagine it more on an object that they've seen before. I think this could also be good for recognizing what would changing the radius and lead on, how would that affect the ability for you to pull out that cork? Would it be easier or less? Going into part 2, I see this again as a problem that could be very easy to do, and I can see it as a breakout session 1. This one isn't complex enough that there's a lot of steps, so you'd only have to be solving for a minimum amount of variables. This would help build confidence in people and really see if they understand that the force of friction equals the friction coefficient multiplied by the normal force, that basic fundamental equation. And again, it would help out because a wine bottle opener is something that everyone is likely to know, and how different aspects you could more easily visualize that with a higher friction of coefficient, the force that you need to pull that cork out is going to be higher. So I could see you changing the variables up to actually solve for different parts of this equation. And if you're still watching this video, comment #WineNight. Thank you. Thank you for watching. And here are my references.